Good day, everyone. This is Alan Schimmel for DevOps.com, and we're here with another great DevOps.com webinar. Today's webinar is sponsored by our friends at SonaType. Before we get started, just a quick note on our GoToWebinar control panel. If you have questions, please do use the question section of the control panel, and you'll see if you hit the little caret or arrow, it'll open up. You can put your questions in there in real time, and our moderators will get to them. We have set aside time for questions, so you don't have to try to remember your question till the end. Please type it in real time. If you have any technical issues, audio problems, the slides aren't progressing, please use our chat section where we have webinar engineers standing by who will take a look at that and try to help. With that being said, though, let us jump into today's webinar. So we live now, I guess, in a post-Equifax world, or until the next big breach anyway. But in post-Equifax, how to trust but verify your software supply chain. And of course, this whole issue of software supply chains and security around it is something that our friends at SonaType have done a tremendous amount of research in. Very happy to be joined today, actually, by VP over at SonaType, Derek Weeks, who's going to be your host for today's webinar.
Excellent.
Derek, are you there?
Yes, I am. Can you hear me?
Fantastic, yes. Derek, why don't you take it away?
Excellent. Thanks, Alan. It's always good to talk to you, and I'm looking forward to seeing you live at our next opportunity, maybe DevOps Enterprise Summit coming up in November. So today, I'm excited to bring a panel discussion together on software supply chains and post-Equifax. And for those of you that are unfamiliar with software supply chains, we're going to cover a little bit about what those are. We're going to talk a little bit about what happened at Equifax, and we're also going to talk about how organizations are kind of changing their perspective on how software is developed, as well as some of the key DevOps principles about knowing your end-to-end ecosystems and environments, understanding practices like building quality in to software development, building security into development practices, and so forth. And for that, I reached out to two people who I know have some great thoughts on this topic as we kind of go through the conversation today. The first is David Blevins, CEO at TomiTribe. And I heard David on I think it might have been an OWASP podcast, but one of my colleagues, Mark Miller, had interviewed him shortly after the Equifax breach was announced, and it was linked to Struts2 as the open source vulnerability that was the front door into that breach. And he had some really interesting commentary on how we need to think about software development and open source components and the responsibility of the open source projects themselves, of developers, and of organizations using open source components. And then we're also joined by Colin Wind over at the Federal Reserve Bank of New York. Colin and I have actually known each other for many, many years. And we used to work back together at HP years ago together. But he has taken a perspective of really understanding the software supply chain within the Federal Reserve Bank of New York and managing their practices, their development practices, even through operations on with an understanding of the software supply chain and how they want to manage it within the bank, and also as the VP of Common Services, talking to the other branches of the Federal Reserve Bank about how they understand the software that they're using, the software stack that's employed there, and how they make sure that quality and security are built in from the beginning. So I know that I went through a brief introductions, but David, do you want to give a little further background on yourself, and then we'll have Colin, you can follow.
Yeah, so you know, I've been involved in open source my entire career. So my first open source project was in 1999, and my friend invited me to work on an open source implementation of some Java EE technologies. And I remember my response to him at the time was, "That sounds great. What's open source?" And so, I've learned a lot about open source over the last several years and seen what works and what doesn't work. And it's led me to fundamentally believe that we're still very, very young in our open source understanding. I kind of think we're at, chapter 2 of the phase. Chapter 1 is it's scary. Chapter 2 is it's really, really awesome. But we don't understand how to really make it successful for us, and we're getting hurt. In terms of what we do, TomiTribe, we basically support companies who use open source and provide them with patches, and in a lot of regards, we are part of the supply chain. So we both produce and support the software and the people who use it. So, this is a topic that's near and dear to our heart. And the more people understand about it, the better off we're all going to be.
Excellent. That's a great intro. Colin, you want to give people a few words about yourself?
Yeah, my name's Colin Wind. I'm the VP of Common Services within the Federal Reserve Bank of New York, and basically what I'm responsible is I have several teams that build and oversee what we call common components and microservices, various frameworks, as well as development services, which is all of the toolings on how we do continuous build, continuous integration, and continuous deployment. And basically, one of the things that we're really responsible for is changing the way that we think about how we're building applications, across the Federal Reserve System. So, Derek?
Excellent. So let's jump into the first segment of our discussion here, and that's the new normal that I think we're all kind of getting our arms around. Post-Equifax. So to start off the discussion, I just want to review some of the things about what's happened or what's transpired. I think all of us have read different stories in the news, maybe to different extents. But earlier this year, on March 7th, the Apache Struts project released a new version of their project, of the component, because there was a critical software vulnerability within that component. It's not the first one from the first vulnerability announced by the Struts project, but the Struts project in particular is one of the better projects out there because virtually every time there's a new vulnerability associated with it, the day that the vulnerability is announced is the day that the new version of that comes out. And on March 7th, they did announce that there was a vulnerability with this component. They released a new version, and notifications were posted throughout the market, if you will, or through different organizations, if you will, about this vulnerability. And through various news channels that I've seen, Equifax was alerted, I think, on March 9th through one of the channels that their CEO had referenced in his testimony through Congress this week, and they went to work on making sure that vulnerability was patched within their environment. Although, as we know now, that patchwork was inconsistent or maybe had some gaps in it to update those components. On March 10th, this is when the first time that the hackers had gained access to the systems at Equifax. And for the next couple of months, they used that entry point to probe around the infrastructure before the large-scale exploit happened at Equifax between the May and July timeframes. And on July 29th, they then went into crisis management about how do we, what happened here, how do we control it, how do we get those systems offline, how do we get any systems updated, who do we involve, etc. And crisis management has been a large-scale effort on their part. But the important thing here, that I look at is not the, yes, there was a vulnerability in Apache Struts. They had Apache Struts within their application infrastructure at Equifax, but the timeline between March 7th and March 10th, if you're using open source components that have known vulnerabilities in them, and you've used those in your development practices for the applications that you're building, those attackers had there was a 3-day window that they took to respond and find a site that had a vulnerability in it that they could begin to exploit. So what was interesting is when I looked at the, sorry, getting to my next slide. When I looked at some of the Gartner research out there, Gartner had referenced this report, which I put into the presentation here, on the average time to exploit after a vulnerability had been announced in 2006 was 45 days. And Gartner had reported up to 2015 that average time to exploit was 15 days. And what we saw with Equifax was it was a 3-day response time between the vulnerability being announced and the exploit that happened. So the time to respond before exploit has decreased dramatically over this 11-year period, where we used to have a lot more time to react, and now we have almost no time to react. And because of that, we have to think about how are we building our software and how are we protecting that infrastructure that we have. So David, maybe I'll turn to you and just ask, as you think about the use of open source components within development, our understanding of what components we're using, and our time to respond to how do we get updates into our code with the safer components? How do you approach this as the CEO of TomiTribe, and how do you approach this as a contributor on open source projects yourself?
That's a lot of questions, but
sorry.
That's okay. That's a wide open field. So, the vulnerability process, I'll just start there, at an open source project starts usually offline. So I think you hit on something key, the public announcement of the fix of that, the time between your ability to respond and was basically, and the first attack was 3 days. We have a couple different aspects to this issue. So one is, obviously, we need to get better at being able to continuously deploy our applications. One of the things I mentioned in the previous webinar that is extremely relevant still and here is we very often think of continuous delivery as delivering business functionality quickly so we can respond to market needs. And that's a really fantastic perspective on it. But it's kind of unrealistic because you don't make new business requirements out of thin air and program them and push them into production in 3 days. But you do need to do that when it comes to vulnerabilities, and especially because the gap is increasingly narrow. So we all have to get better at that in terms of our own capabilities of being able to take in and roll out software. But the other aspect of that is you really need to have a relationship with somebody who's close to the software, because they know in advance of the fix being publicly released that a vulnerability is there and is being addressed. And if you had a relationship with the people who developed the software, they could tell you that this is going on. But they can't publicly announce it, because the second you publicly announce that there's a vulnerability and it isn't fixed, that 3 days becomes 15 days in the wrong direction. So yeah. we have a challenge as open source creators that we would like to tell people that there is a vulnerability and we're working on it, but obviously that puts everybody at risk and there is no solution. So we have to keep our mouths shut, and we have to get our heads down and work on it as quickly as we can, and get a patch out, and then go through the process of getting things released. At Apache specifically, that takes about 3 days, but in practice, it's a week to 2 weeks. So there is the opportunity for more lead time than 3 days, but only if you're connected to people who are developing the software. And it's a key thing that people really need to understand, because it can add to your lead time significantly. If you're just going to sit there and consume open source software as a bystander, then you are your lead time is going to shrink. You're going to get the same heads up that the hackers get, and then you have to always be working much faster than they are, and they're very motivated.
Yeah, extremely motivated. Those are great. It's a great point about how to think about. You need to have a relationship or some communication structure or some intelligence about what available to you about what's the quality of the components, in quality, including security in this particular discussion. Colin, so at the Federal Reserve Bank, like every other development organization or organization that has development teams on the planet, you're not developing all of your software from scratch there, and you're relying on outside sources of open source components or otherwise within your development practices. How do you think about this kind of situation of the time to respond before exploits, and how do you guys begin to manage that or get a handle on it?
Yeah, there's probably two big points. One is, how do we actually approach, if we get a patch, how do we roll that forward into production, right? And we have lots of different types of applications. Some applications that we update quite frequently, and other applications where there's just really not the changing business requirements, and we don't do very frequent releases at all. But this is where we get into more of a, into a defensive posture. We can call it defensive DevOps if you want, where there's going to be these vulnerabilities. There's going to be more of them coming down the pipeline. How do we actually redeploy an application that's got, say, some updated library but no change to the business function? It's probably an easier thing to do than if we have new business requirements. But what are the steps that we go through that, right? Can we build an application in an automated fashion? Can we do automated regression testing, and to what level, right? Do you get 70% of your tests are automated, and what's the code coverage there for these testing? And then eventually, how do you actually go through to dev, then QA, and eventually into production, and what's the timeline? And probably what's got everyone somewhat concerned, if you go to the previous slide, right, that's the scary thing, is people always thought they would have time with these vulnerabilities. It seems like the hackers are very much fine-tuned looking for vulnerabilities, and that they can turn around and exploit them pretty much within 3 days. People now need to re-look at how are we going to build and deploy our applications in a timely fashion. So that's probably one big focus. The other focus is going to be, making sure that we're using libraries that have some level of responsiveness. In this case, Apache fixed it within 3 days. I'm sure, Derek, you can talk about some of the stats, whereas probably the mean time to fix on average for some of the open source libraries is a lot longer. So this is now what we have to start to look at is, hey, are we using the right libraries? Are we using the right libraries where there's actually these companies that are supporting these libraries, or people supporting these libraries that are going to be very responsive, so that when a vulnerability is found, there is actually going to be a patch produced quickly. So to me, it's no different than, I'll pick on Ford, right? With the Ford supply chain, if they have a vendor that's not being very responsive to fixing issues, they'll quite happily drop that vendor. We have to start to look at, okay, are we picking the right vendors? Yeah, there might be some really cool library, but if they're not being responsive to vulnerabilities, should we look elsewhere and leverage maybe another library that might not have as nice features, but it's going to be safer over the long run, because no one wants to be the next Equifax.
Mm-hmm. Yeah, I think I want to play back to a point that David had made earlier about, you have a business requirement that you planned for your product, and you want to roll that out into the development process, into testing, into production, and so forth. And no one really thinks about, taking a business requirement and moving it into production, within 3 days from beginning to end. But when it comes to things like this, that response time of something has changed, I have intelligence about, the situation has changed, whether that's a notification from the Apache Struts project or other open source projects or tooling that you might have that reveals things have changed. But you need to have the tools and practices and processes, and in many cases the automation in place to be able to take something from, here's a requirement that we have right now, there's a vulnerability in this infrastructure, to I have the fix in production, in under 3 days before I'm exploited. If that's now the new normal or the new average, then we need to think about, not only are we prepared to move, business requirements into the, and functional requirements into production faster, but in cases of crises like this particular one related to Struts, can we move anything into production within 3 days before we lend ourselves to crisis situations? So transitioning to the next topic, software supply chain. So this is a concept that really originated at Sonotype, that we started talking about software supply chains probably 4 or 5 years ago, and telling people you need to be aware of your software supply chains and what is feeding your development and operations practices. But it's as with anything, when it originates, no one's talking about it. And now, if you do Google searches on software supply chains, you'll see that Wired even had an article on it last week, among a number of other organizations. But the software supply chains are fairly simple to understand, and they act just like supply chains in any other industry. You have suppliers, in this case open source projects. You have warehouses, central component repositories like Maven Central, npmjs.org, python.org, or the NuGet Gallery, or even Docker Hub, for that matter, is a central component warehouse. The manufacturers or software development teams or operations teams are pulling these components from those warehouses and using those to create their finished goods. So these software supply chains are used by every development organization on the planet now. Part of that is reflective in some of the data that we've collected and published over the years within the software supply chain report at Sonotype. When we look at just back a couple of years to the beginning of 2014, when I joined Sonotype, we had just had 13 billion component download requests from Maven Central. Last year we had 52 billion. NPM or JavaScript packages, they've seen a huge increase in package downloads from just under 5 million a couple of years ago to 59 billion. And I think I saw a tweet from Lori Voss maybe a couple of weeks ago that said they're now at 100 million run rate for package downloads. So the volume of consumption, not only the volume of supply, the number of projects that's out there is grown tremendously. The volume of consumption has also grown tremendously. Docker packages are expected to grow from 6 billion pulls from Docker Hub to 12 billion this year. And what that means is 80 to 90% of our modern infrastructure or modern applications, as well as the operational side, the containerized side of applications, is really more of the norm of what's in our code, what's in our applications, what's in our operational infrastructure. Colin, maybe I'll start with you this time. How do you think about the software supply chain that you're managing at the Federal Reserve Bank?
So we have to manage this very carefully because the nature of what we do, right? We're always worried, about the quality of the software that we're producing. And if you go back, if you actually stay on that slide, right, over 80% of the software, right, is really getting downloaded off the internet. So we're very worried about the quality of the software that we're downloading. And then in addition to that, right, the quality of the software that we're writing that sits on top of that. So we kind of break things into kind of three chunks. So we worry about the open source software, so making sure that we have the controls around which software is getting downloaded. So if you go back to that slide about the different chains, we download from various external sources, and we have a local copy, which you can see and you can consider that as our warehouse. So we have a local warehouse that we can ensure that people pull from, and we only want people to pull from the local warehouse, so we get much more control on what people are actually downloading and put in processes that sit on top of that. So then the other thing that we worry about is, what would be our common components that we're building in-house, or our microservices that we're building in-house. What's the level of quality? Because that gets distributed amongst lots of other applications, just like the open source software. And so the impact on our microservices and common components can be quite large as well. So we're very worried about, the software quality and that. And then the last piece is the individual applications that we're building, making sure that there's very high level of quality within that, and that kind of reduces the overall aspects to this. In addition to all of this, the other thing that we worry about is the open source policies. There's a lot of different open source licenses out there, and they can have an impact on how and who we deploy to within the Federal Reserve system, right? So some of our applications are actually consumed outside, some are only consumed within the Federal Reserve Bank of New York, and some are actually consumed around the different reserve banks, which are different legal entities. So we actually are very careful about the open source licenses, the open source software and their associated licenses that we use, and we actually don't want to use certain types of licenses, so we'll actually block people from using the software based upon the license. And that's an evolving item there, as different versions might switch licenses as we go forward. And I'm sure you've seen that in the market as well, Derek.
Yeah, I think one of the things that some people don't comprehend, and we've reported on this again for years through our software supply chain report, is every organization has these software supply chains. If you're using open source projects or you're using containers, you're taking advantage of the software supply chain. You didn't develop this software yourself. You downloaded it freely from the internet. Just looking at Java components alone, where we manage Maven Central, we can see the organizations downloading. The average organization last year downloaded 125,000 Java components. If you're developing in Java and Ruby and Python and you're using containers, you're bringing even more than that, more than that volume of components internally, probably a couple 100,000 components a year to millions in some organizations. So when you think about it, it's not only the fact that there is this software supply chain, but it's operating at much larger volumes than I think what people recognize. So David, when we think about, or when you think about TomiTribe, how have you come to think about software supply chains and how you participate in them as either suppliers or users?
Yeah, well, so I'll tell you, we have a lot of people who approach us who are, enlightened and understand the inherent risks about the open source that they're using, and they usually engage us to commit to long-term fixes and security patches for the open source software that they use, because they are very aware of some basic realities of our industry. Some of them that are very scary. So, for example, I see a lot of people who blanket approve things by open source license. So they say, okay, anything that's Apache licensed is okay here. And then a lot of code comes in and they don't really know where it comes from. And that you're once again very, very open to risk. The other one is I see people treat Apache, for example, specifically as a vendor, and they are not. So, the amount of donations that Apache gets per year is about $1 million. That runs all of the Apache Software Foundation. There is no money in there for any development. So there is basically 5,000 contributors across the world who contribute to Apache. So it is a mistake to view Apache as a vendor and get any form of safe feeling from that. There is no security there. When you look at the people who actually contribute to these projects, so mind you, like I say, Apache is not a vendor. They don't pay for any development at all. They just simply try to provide infrastructure for the projects there. When you look at actually who's producing the software, there are some scary realities. You have typically two forms of contributors that you might see. One is the lonely person of working on open source software in their spare time. And yes, they may be producing patches for you on a regular basis, and you may gain a sense of security, but there is no guarantee that they will be there next month or the month after that or even next year. Software projects typically do not make announcements on when the software goes end of life. There are very few projects that do. Tomcat is one of them. So for example, all the people on Tomcat have agreed Tomcat 8.0 is going end of life next June. So everybody has 1 year to take a look at it, and after September, there's going to be no security fixes for it at all. And so there's all these gaps. There's the biggest misunderstanding about where open source comes from is a lot of open source comes from large corporate contributors. And so you will see a very real and a very, even pace of contributions. But large corporate contributors make the same cost-benefit analysis that we do as open source consumers. They decide, do I like carrying so much weight in this project? Can I go over to another place and team up with somebody else and maybe lower my costs? And when they do that, they drop the project abruptly and quickly and sharply. So a great example of that is in Apache. There is a project called OpenJPA. Major contributor to that was IBM. They decided to go work with Oracle on Eclipse Link instead, and OpenJPA went flat immediately. Apache Geronimo was very strong for about 5 years and then completely dead. So companies who are basing their safety on what they currently see as responsiveness in the project, they don't have a paid relationship with the people who produce that software. They don't have any stability on that software at all. They're simply observing what I'm getting now, but that status can change abruptly and quickly without notice. So you absolutely have to learn who is writing the software. It is not Apache. Apache does not write the software. If you use software from the Eclipse Foundation does not write the software. You have to learn who's actually writing this stuff, why they're doing it, and like I said, you need to get a relationship with them. That is a major gap that we stop at a brand, and usually the brand is the open source foundation, and we feel the sense of safety, but it is not the reality. And in the case of the Equifax stuff, it's go ahead.
Yeah, I was Go ahead, finish your point on Equifax, and then I'll.
Well, I was going to say, in the
lead.
case of the Equifax thing, that there's not. That's one of those projects where the fixed time wasn't 3 days; it was much longer. It happened all offline, and the person who put out the very professional-looking, statements on Apache's behalf, is an independent contributor to Struts. And during the vulnerability, just after the vulnerability, he went on vacation, because he had to, and he's just had a child, right? So this is who everybody who's using Struts, they're relying on him. And he's a great guy, but that's not the reliability that we're imagining that we have. We imagine this big entity as a powerhouse of open source contribution, but it isn't. And
I think that's
a little bit.
Yeah, I think that's an excellent point, because we shouldn't be we probably need to evaluate open source from several different aspects, right? Around the community, around the popularity, the currency, how frequently it's updated, how frequently the patches are produced, because that's if you equate that to how Ford looks at their vendors, right? They look at vendors that supply their products in terms of reliability, financial stability, etc. So again, I would agree. You don't just use any old open source. You have to be very careful and prudent about the open source that you're actually going to use and put into your own supply chain, right? So I think that's one of the critical things that has been shown by this Equifax breach is, people are suddenly waking up and realizing how much open source they're using and how deep it goes into their organization. And this is also true for some of the closed source vendors as well, because at least with open source, right, you can look at some of the history with that and the different dimensions to trust, but you don't know what some of the closed source vendors have actually done. Are they actually using these same products? Chances are a lot of them are, but are they actually updating their product in response to these issues?
Yeah, that's a very critical and key one. Most software we get does incorporate a large amount of open source, even if we're paying for that software. That software is going to have vulnerabilities, and if the vendor is not uptaking it, that's a very critical thing. I do want to touch very explicitly on one point, and that is the statements being made a lot. We need to get good at evaluating. That's a dangerous perspective if we stop there. So you have basically chosen. We are choosing to consume open source software instead of building it ourselves. And this maybe gets to the next question, but you have to become engaged in some way. So you're either going to become engaged in the open source project and contribute your time, or you're going to find someone who you can contribute your dollars to. But if you aren't feeding the ecosystem you're standing your company on, you are playing a much riskier game of simply evaluating the free food you get for safety. So open source is an opportunity for cost savings, but if that comes to the complete, if we as organizations are not participating in that ecosystem in terms of either like if open source percent is 80% of the software that we consume, but 10% of our budget or time, that's a problem. And so we need to be able to figure out how to contribute to those projects such that we are there also protecting our own investment, because effectively we own that code. You can either protect it internally, or you can go to the project and protect it there, or you need to take a traditional vendor perspective and pay someone to protect it for you. But yeah, go ahead.
I think it's a point. The point that we're trying to make is certainly not anti-open source, and that you're not supposed to use this stuff. But I think all of us are kind of making the point of, look, we're all using it, and in fact, we're using it in giant volumes, and that's not going to stop. In fact, we're only going to use more of this because it makes everyone more efficient in terms of what they're doing, and development practices, time to market requirements, developer efficiency, what have you. But I think that what we're saying is, while we're consuming, we can't consume blindly, because when you consume blindly, whether that's on a known security vulnerability in Apache Struts or the thousands of other open source vulnerabilities that are out there amongst the code, or within the projects, or even the license risk, as Colin had mentioned before, blind consumption is not the way to go. I think everyone's had a chance to look at my slide here, in terms of data I pulled from the software supply chain report about, there are projects out there that have known vulnerabilities. There are projects like we've discussed, like the Apache Struts project, where if there's a known vulnerability, they've actually provided a fix. That's only the case within the Java ecosystem. That's one of the better ecosystems. 16% of the time, if there's a vulnerability, it's actually fixed in a subsequent release of that project. And in those cases, when it is fixed, the mean time to repair is 233 days. So Apache Struts is not the norm by any means. The fact that they have a vulnerability and release the fix the day that the vulnerability is publicly announced, even if there's work behind the scenes, there's the average here for the open source projects that do have vulnerabilities is not terrific. And as Colin says, you need to look at suppliers that you're using to understand who has the best track records out there. When just to give you kind of more of a sense of the ecosystem out there, over the last 3 years, out of all the downloads from the Maven Central Repository, we used to see 6.2%. Last year it was 5.5%, which doesn't seem like that many or that high a percentage of vulnerable components being downloaded. But when you think about it, it's 1 in 18 components you're downloading has a known vulnerability the day you're downloading it. And your organization is downloading over 100,000 or maybe a couple 100,000 or a couple million. You're bringing in a lot of vulnerable software. And if you bring in, potential license risk and other things to that, again, going back to, it's not anti-open source. It's use as much as you can, but use responsibly, and certainly don't use blindly in your efforts. So I'll stop there, and maybe Colin can come in and comment on, consumption practices.
And I think this is kind of the key thing of, it all depends on the type of applications, and all depends on your risk appetite, and you need to make, these types of decisions based upon that. So you don't want your financial system, right, to have vulnerabilities in there that chances are won't get fixed on average for 200 days, right? Do you want to make a risk-based decision on, is that okay for some other applications? I'll pick on, the cafeteria menu system, right? You might decide it's okay for us for some of these applications to have, higher level of risk using your software from unproven, contributors or vendors. So that really gets into a lot of the decisions. And to me, this is no different than what companies have been doing for many years with physical, vendors working on when building actual products, right? We need to start to leverage the thoughts that people have gone in. And I'll pick on Ford, right? That the companies like Ford have built up over years on how you manage your vendors in the supply chain, and look at how Ford has done it and these other companies have done it, and leverage kind of the best practices and apply that to this, the software supply chain as well. Because if we don't, we're going to run into issues, and we saw what happened to Equifax, right?
Yeah. Ford or Toyota or Pfizer don't blindly source components, ingredients, or parts for their products. They're looking at, we can use any supplier in the world, in fact, to get those particular ingredients, but we're going to use the highest quality suppliers, the most responsive, suppliers, the ones that, meet our needs by both, function and safety standards and quality standards. And there, in this particular chart that I stole from the Gartner report, everyone on this call is going to get a copy of the Trusted Software Supply Chains report that Gartner wrote earlier this year. But it talks about, you have this software supply chain, and it's using either trusted or untrusted or partially trusted components. But there's a burden to verify based on the level of trust, right? If I built it myself, it's my own proprietary component, fully trusted, right? Or if it comes from, the Apache Struts project, maybe partially trusted because I didn't write that code myself, as David was saying. But there is a burden to verify the quality, security, licenses, and so forth. David, what do you think about this image in terms of the kind of trusted to untrusted spectrum here?
I guess I could give a really clear statement on using it to try and communicate what I've been trying to say. So those who are kind of whitelisting open source by license and looking no further than that, they have an untrusted relationship with that open source. That is not enough to say whether or not that open source is safe or not. And by the way, like the Apache Software Foundation license and most licenses for open source have no vulnerability, no liability, right? So, if we were to walk into a procurement office and say, hey, let's use this code, we get no ability to sue anybody if it goes badly. Let's use it right now. We don't actually know who made it. They would say, hey, cool. Where'd you find it? I don't know, but it's under this license. Let's grab it. So anybody who has blanketed stuff just by license and they don't know where it comes from, even the software foundation that makes it, they have an untrusted relationship. If you are at least aware that, say, this is coming from the Apache Software Foundation, you have a partially trusted relationship, but it's very much on thin ice. You need to understand who's making this stuff and why. So those who are just looking at, the software foundation it comes from, need to understand that there's nobody getting paid by the software foundation. It's a brand and doesn't have any SLAs or anything associated with it. So where they may be measuring how often it comes, the security fixes come, it is still only a partially trusted source. Now, if you go one step further and you go, who on the project is writing the majority of the source, and you contact them and you develop a relationship with them, you now have a trusted source. And it is that easy. So for example, a lot of people who are using one of the pieces of software that we contribute to, Apache Tomi, they'll look at the project and they see that 90% of the commits come from us. And so they come to us in the developer relationship, and we give them the fixes right there in the open source, but we give them to them in advance, and we give them to them far in advance of the CVE being announced. So I think it's one critical thing to note, that the relationship between the struts fix and the CVE coming out 3 days later, there's coordination going on behind the scenes with Mitri and the people who release the CVEs to the world. These CVEs are filed sometimes weeks or months in advance of it being announced. The Apache Software Foundation and Mitri, we will hold publicizing the CVE until there is a fix. So it looks like Struts has a super responsive 3-day turnaround. It wasn't the case. We actually coordinated behind the scenes, and then when a fix was available, we coordinate both the release of the software and the public announcement of the CVE. So until that thing is fixed, it doesn't happen. But again, now you need to know who's doing the fixing. And if you have a relationship with that person, you have a trusted relationship. If you don't have a relationship with that person or that entity, you have a partially trusted relationship. So those of us who want to get to the trusted side need to find out who's actually writing the software and develop a relationship.
Yeah, and I think part of this also plays to, you know, I think there's a reality of the situation that you know, I'm certainly aware of, and I think more people are aware of if they've looked at their software supply chains, understanding how much is flowing through them, how many different components or containers that they're using are flowing through them. You know, the average organization's using 3,000 to 5,000 suppliers within their organizations for different projects, you know, that they're relying on. And you know, part of the title on this slide is how can technology and process help, right? So there's part that's, you know, having the relationship certainly with some of your key projects, you know, is going to be advantageous, as David has been saying. But there's also technology that can help you, you know, assess and validate, you know, the components that you have and what their licenses are, and if there are any security vulnerabilities, and if there are any, you know, known better versions out there of what you're choosing, and making those available to developers, you know, early and everywhere across the life cycle. That there are, you know, it's not just human relationships per se, but there are technologies and processes out there in the DevSecOps community and DevOps community that can actually help organizations understand these varied levels of trust. So the final topic, yeah, go ahead, Colin.
Yeah, I think that's a great point, because if you look at, you know, what we've been talking about with open source, we actually do naturally with a lot of you know, purchase products. You know, so if you look at everything is kind of risk-based, you know, we are talking about open source licenses. Really, that's just a form of legal risk, right? Mm-hmm. There's the risk in security, and there's certainly, you know, the ways to do that is there's a lot of products out there that help you with that, the supportability and the stability, and this is no different than we do today with purchase products, right? To have as part of that, as you know, if you think you go through an RFP, we just need to start to think through the same types of risks within our open source as well.
I couldn't agree more. I mean, we have a very strong procurement process that a lot of corporations go through if that software costs $1, and therefore it goes through a set of very critical eyes that protect the business from the risks associated with that software, and the vendor who's behind that software is torn apart, you know, and that's good. But when open source software walks into an organization, a lot of times it's brought in by just, you know, our developers who do not understand business risk. And so, yeah,
and I think that the critical aspect to that is, you know, the volume of open source has gotten so huge with the number of libraries being downloaded. You know, how do you help the developers make the right decisions? And I think we have to throw technology. No longer can it be a manual processes. You know, you're going to have the technology that enables people to making the right risk-based decisions on this.
Yeah, I think I couldn't agree more. You know, we also use. I'm just going to plug, you know, the Sonotypes scanning. We use that critically to rely on, you know, to deliver fixes to our people. But I would say, you know, procurement needs to be involved in the process that developers are in getting, you know, open source into the organization. And our procurement processes have to evolve because, as you mentioned, the software that we purchase is also using a whole bunch of open source software. So there's really no getting away from this concept that we do need to have a reform of our procurement process so that they finally understand open source, can participate in the onboarding of open source in our corporations, and we can all be making much smarter decisions. because I believe the world and how we consume software has changed, but I haven't seen a lot of procurement processes change. And that has to get revved.
Yeah, I think it's a good point. And, procurement is something that's often talked about in terms of open source components, or at least, broadly. But when you think of it as a software supply chain, procurement is, well, who's able to download components and where are they able to download components from? As Colin had mentioned earlier, developers at the Federal Reserve Bank have to go to a local warehouse or a local repository manager to get their components, because that's the approved source that you can procure from internally, right? But for the majority of organizations, if you have 200 developers or 2,000 developers, your procurement organization is 200 or 2,000 people in procurement, right? And as Colin was referencing Ford, several times, like Ford doesn't have 2,000 people in procurement for the parts on this year's, Ford Mustang. There's a group that understands what parts are needed, what parts do we have to choose from, which are the highest quality suppliers, and we'll procure those and feed those in. And while that might sound limiting, it's actually just procuring the components or the parts that you need with some intelligence about what is the quality of these things and what's the track record of these suppliers. And if you actually manage it, you can see in the slide that the organizations that manage their software supply chains can reduce defects by 63%, at the finished goods level. And from, downloading them from central warehouses to finished goods, it's a 69% improvement overall in weeding out the components that don't make the cut, that aren't, don't fit in the governance programs. But I want to close off on maybe just some quick points, because I know we're at the end of time. But when we look at the software supply chains, and if we're taking in just any part, are we as software development organizations ultimately liable, or are we as organizations that are consuming these parts and putting them into the finished goods and offering those finished goods to customers? Are we ultimately liable for those practices of what parts we choose and put into the products that we're selling to our customers? The UK National Cybersecurity Strategy brings this up. We've seen liability come up in terms of the Equifax discussions recently. Are they responsible for baking that part into their application infrastructure or not repairing it fast enough? And we've seen other cases come up in the news that we've documented in our software supply chain report. But maybe quickly, because we just have a couple of minutes, David and then Colin, what do you think about software liability as a concern in the industry?
Well, I guess it depends if you mean in spirit or legally. If you mean legally. Then we are absolutely 100% liable, and that's not subjective. So open source foundations have licenses that limit their liability perfectly. You have, as a consumer of open source, zero legal ability of any sort to sue them for any issue associated with that software. It's as is. So when you bring it into your corporation, you have no throat to choke. You are legally on the hook for that 100%. And if you knowingly incorporate that into a greater work and offer that to your customers, you have then made a derived work of it, and now your surface area for liability has massively increased, and this needs to be understood. So, you have to have some means to protect yourself, because you can't point the finger. So, there was a moment during the Equifax thing where Equifax attempted to hint that this was an issue on the Apache side. But had they decided that it was, there would be nothing they could do about it other than to try and make Apache look bad, because they had used it under a license that didn't give them any legal recourse. So there you go, end of story. The liability stops at you. the consumer.
Colin, what's your perspective?
Oh, I'm not a legal person, but I think whether we're liable or not, I think it behooves us, right, for to make sure we're doing the best that we can, right? So from an external perspective, making sure what we're downloading and putting into our applications, we got to be, I would say, careful and prudent and look at the risk of that, as well as once it's inside, we got to look at, the inside, the delivery pipeline, and make sure that we have defense in depth to avoid vulnerabilities, whether they're externally generated or internally generated into the overall supply chain for the applications that we're building. Some of the things that, we're the Federal Reserve System or the Federal Reserve Bank of New York, right? We're very worried about security. I would say we're paranoid about it. So we're very careful and prudent. And you can see that, we don't want to be another Equifax. And, I think people need to start to look at the supply chain, because if we don't, there's going to be more and more of these as more and more vulnerabilities are exploited by hackers.
Yeah. I would just simply add to that and say the days of us not knowing where our food comes from, they're over. We have to know where our food comes from. We have to know how to measure and protect our food. That's where you guys come in. You guys have amazing tools to allow people to grade the food, and that's a massive part of the problem. But we can't just simply consume this stuff without any awareness of it, where it comes from, or how safe it is.
Yeah. Colin and David, I can't thank you guys enough. I knew it was going to be a great conversation getting you guys, on the webinar today to really walk through this and I think open people's eyes and give people, a lot to think about. And thanks to DevOps.com for hosting this great discussion today. Just for everyone listening, the recording of this webinar will be on DevOps.com later. Hopefully you enjoyed it as much as we did. I think it's really critical that we share this information with our colleagues around the organization, so I encourage you to take the link from DevOps.com, share it with your colleagues, open the discussions about what do we know about our software supply chains. I'll invite all of you to read this Gartner report we're going to send to everyone that attended here on managing digital trust in the software development cycle, which talks about the trusted software supply chains or untrusted software supply chains we're all using. I know we're out of time here. I really appreciate everyone joining us today. And again, thank you, Colin. Thank you, David. Thanks, Alan Schimmel, for introducing us. And if you have any questions, feel free to reach out to us. Week's tweets on Twitter and the other Twitter addresses from Colin and David were up at the beginning, and you'll be able to see those on the recording as well. So thanks a lot, everyone. Have a great day, and we'll talk to you soon.